Okay, so once I get my numerator and denominator on the graph, my numerator and my denominator helps me find my zeros and my asymptotes. If I find some values on this graph, and I'm going to go with the pi over 4 family, in the first quadrant, pi over 4 is 1, so at pi over 4, smack dab in the middle, that's going to be 1. All that does is give me a direction of this graph. And I know what happens around asymptotes. We learned that in Algebra 2, that it's got to approach the asymptote, but it will never cross it. That's a vertical asymptote. So this pi over 4 helps me find an additional point, which also helps me give direction to where this graph goes. Between pi over 2 and pi, I'm going to stick with the pi over 4 family because they're very easy to work with. So here's pi over 4. Between pi over 2 and pi, that is in the second quadrant. And in the second quadrant, that would give me 3 pi over 4. And the tangent of 3 pi over 4 happens to be -1. Because then I would have a negative cosine and a positive sine. I flipped it the wrong way. A positive sine and a negative cosine. So positive square root of 2 over 2 divided by negative square root of 2 over 2 gives me -1. And so that gives me another point on this graph. And again, there are a whole bunch of other points, but what this does is gives me direction. It tells me which way that tangent goes, and I know it's going to approach the axis. And now I'll continue this. In the third quadrant, that pi over 4 would be 5 pi over 4. That one's going to be +1, and again, it gives me direction for my tangent. So I graphed the tangent of 5 pi over 4. And then I'll finish in the last quadrant between 3 pi over 2 and pi over 2, and that guy is 7 pi over 4, and the tangent of 7 pi over 4 is -1. So that gives me, again, direction for this piece. And so that's how the graph comes together. Now, I did a shortened version of how it comes together. We could have found all of the points, pi over 6, pi over 3, plotted them all. But it's not necessary as long as we get the direction. This is how our tangent looks. Do you have to go through all of this every time you graph a tangent? No, I hope not. I hope that you put it together with maybe the ghost graph of the denominator and figure it out from there. You don't have to put all of that stuff on there, but that is how it looks like this, okay? Secant is our next guy. Now I chose secant to be the second graph because secant also has a denominator of cosine. Because remember, secant is 1 over the cosine. It just doesn't have a numerator. It's the reciprocal of the cosine. And when the cosine is 0, just like in the tangent, when the cosine is 0, the secant is undefined. And our secant graph looks like this. I have my 4 tick marks. It has asymptotes the same place that the tangent does. And then it is the reciprocal of the cosine, so the cosine flipped. And I'll explain that in more detail once we start graphing. It actually has these continue forever, and then just like sine and cosine, these things go on and on and on forever. I could continue to draw. This is just within one lap around the unit circle. So again, let's kind of slow down that process. I'll show you why it looks like that. I hope you use those indicators on why it looks like that. And then you can do your shortcuts along the way. Just kind of get the little things on there that are important and remember what the basic graph looks like. So here's my graph again. Again, I start with my 4 tick marks based off of one lap around the unit circle. Again, I have an amplitude here on my sine and cosine graph, an amplitude of 1, which means it's going to top out at 1, bottom out at -1. Slide this up. I think I gave people enough time to finish off that tangent graph. Again, I'm going to graph the cosine. Just a quick sort of cosine graph to help me remember where my asymptotes are. And often when I graph, I don't actually graph this sort of ghost graph on there. I just visualize where it's going to be, and then that helps me find where my asymptotes are. And so again, my asymptotes happen when the cosine crosses the axis. That's known as a 0. So when the cosine is 0, the denominator is 0, therefore the function is undefined, and that shows up in our graph as this imaginary line that the graph will never cross. All right, now, secant has nothing to do with sine at all. Tangent does, so I graphed both cosine and sine. Secant has nothing to do with sine at all. It only has to do with cosine, and it's the reciprocal of cosine. And if you envision what a reciprocal is, the really kind of short, generic description of is it's flipped, right? Reciprocal means you flip it. You just turn it over. And so if I picture here where my cosine is curved down, my secant will flip and curve up. But they do share this point at 1, and that's because when I flip 1, I get 1, right? The reciprocal of 1 is 1, so when the cosine is 1, so is the secant. So they share that 1 point, and that's why the little ghost graph is very helpful. They have that point in common. In between the second and the third, they also have another point in common because the reciprocal of -1 is -1. And again, if you think about a reciprocal, it's a flip. So if my cosine is curved up, my secant is curved down. It just doesn't flow and connect because it's blocked by those asymptotes. But you can see visually they have that flip look. And then they share another point over here at 2 pi. That's also when the cosine is 1, and that's when my secant flips upward again. Do you kind of get what's going on? Good-ish? All right. So cosecant and cotangent are going to be very similar, except for we're going to be dealing with sine as the denominator. When sine becomes the denominator, then the asymptotes move. But the concept is the same. So let's start with cosecant. Cosecant looks like this. 1, 2, 3, 4. Again, 4 little tick marks based off of the 4 quadrants. I'm going to change color because my asymptote is on the axis. So I have an asymptote on the y-axis. I skip the first tick mark, I go to the second tick mark. Skip the third, go to the fourth. And then my cosecant looks very similar to the secant, just shifted. And that's pretty much what sine and cosine are too. They look like each other, they're just shifted. In fact, there are times when I have a sine graph and a cosine graph like on the same graph, and if I were to ask which one it is, it's hard to tell unless I know what the shifts are. So I could give an equation for a graph of sine that would graph exactly as a graph of cosine. And that's how cosecant and secant are. So again, this is the basic graph. This is what the parent function of cosecant looks like. And now we'll put it together and go through the y on it, okay? So again, 1, 2, 3, 4. Nothing done to my angle. So 2 pi and pi over 2, 3 pi over 2, 1, and negative 1. Cosecant is 1 over the sine. So I'll graph my sine as a ghost graph, and I'll use that to help me find my asymptotes and where the cosecant is. So my asymptotes are on the axis where the sine crosses the x-axis, so at pi and at 2 pi. That's exactly where the sine is 0. The sine is 0 at pi, it's at 0 at 2 pi, it's 0 at 0 pi. And then I will graph the rest of my function, and that is they share a point at 1, because again, cosecant is the reciprocal of sine, which means I flip it. When I flip 1, I get 1. And then I flip the graph for the rest of it. They share negative 1 and a flip. And just like sine and cosine look very similar, secant and cosecant look very similar, tangent and cotangent also look very similar. They have a similar feel to them. They are the only one, though, that you can tell immediately if it is tangent or cotangent just by the direction that the little flips go up, okay? So where our tangent, if you look at it in the center area, it's kind of up. Am I doing it? Nope, I'm doing it backwards. So it's up on that left-hand side and down on the right-hand side. And I'm saying it backwards too again. Up on the, it's all backwards because I'm backwards. I'm facing you. Up on the right, down on the left. You get what I'm saying? Okay? When we graph our cotangent, it will have that flip feel. All right? So let's get that going. Cotangent is cosine over sine. And again, that denominator is the one that causes an issue when I graph it. Oh, I didn't graph what it looks like. I'll do that real quick. This guy looks like this. There we go. So again, where tangents got this feel, cotangent has the inverse feel. So we'll make our graph. Because nothing is done to the angle, we'll still base it off of one lap around the unit circle. I have nothing in front, so I'm going to assume that that amplitude of my sine and cosine is 1. I'm going to sketch a ghost graph of my sine. I keep saying graphed. I don't know why, because I think it's ghost and then my mouth keeps wanting to say tease. So I graphed the sine, and that being the denominator tells me when I have zeros in the denominator. My zeros happen when the sine crosses the axis, and it also tells me where my asymptotes are. And then when I graph the cosine will be 0 at pi over 2 and 3 pi over 2. And when the cosine is 0, that'll put 0 in the numerator. 0 divided by a number is 0, so that means the cotangent will also be 0. So I can say that. See that with my ghost graph. I said it right that time. Oops. Okay. So again, I can put my points on here. Pink seems like a good color. And I can go ahead and I can use that concept of pi over 4 as well to help me find my direction. The cotangent of pi over 4 is 1, just like the tangent is. And that's because it would be square root of 2 over 2 over square root of 2 over 2. The cosine and the sine are the same. So I have this point here at 1, and that helps me figure out where my cotangent goes. And I can continue to go through that process. I have one at -1 in the second quadrant because the cosine is negative and the sine is positive. And then in the third quadrant, and I know these aren't quadrants, I just use them, I use them in my brain. I like have them defined kind of as a quadrant. Between pi and 3 pi over 2 is the third quadrant. Between pi and 3 pi over 2 is the third quadrant. In the third quadrant, both the sine and the cosine are positive or negative, which is going to make a positive quotient. Negative divided by negative. And then my last one in the fourth quadrant, I have one of each sign, and that's going to make a negative value. So there is my cotangent. All right. I need to go back up to the top and start talking about the important things. We have not put any shifts in here yet, but we do have periods and amplitudes, potentially, because we have graphs. So I want to talk about the period and amplitude of each of these. I'm going to start with this bottom one, the one that we just did, and I want to define period. Period is how long this graph takes to repeat itself. That is the definition of period. And when we were graphing cosine and sine, it took the whole distance to repeat itself. How long does it take tangent to repeat itself?
It takes
Half the amount of time. So our period for our tangent will always be half of what the sine and the cosine would be. And in this case, the period is pi. And then we're going to define amplitude. Amplitude is how far the highest point of the graph is from the center. How far is the highest point of this cotangent graph from the center? Highest point. Infinite. What do these arrows mean? Goes forever and ever and ever and ever. I only graphed a point, but the highest point goes up there. So when we talk about amplitude, it is not applicable for cotangent. Because we can't ever get to infinity, so I can't give a measure. So I just say not applicable. Let's go to cosecant. Working backwards here. Period and amplitude. How long does it take for the cosecant to repeat itself? The full time, just as long as it takes sine and cosine. So in this case, it's going to be as long as sine and cosine, that is 2 pi. How about my amplitude? From the center of the graph, how far away is the highest point? Infinite. So we do not have an amplitude again. In fact, we can just hurry up and say for the rest of them, right? Amplitude, not applicable for these. So when I talk about tangent, and when I talk about secant, I do not have an amplitude. How about period? Period for secant, how long does it take to repeat itself? 2 pi, the full way. And then for tangent, how long does it take for it to repeat itself? I think I heard somebody say pi, half the time. Yep. It goes up, it goes down. It goes up, it goes down. That's a repeat, right? So pi. So the only way that the way that it makes sense to me to define that period as half of what sine and cosine would be is that it takes two trig functions to make cosine, so it's going to get the job done in half the time, right? Because we're doing double the work, two trig functions. So I always say it gets the job done in half the time, so it repeats itself in half the time of sine or cosine. When it comes to cosecant and secant, it's going to take the whole way. It's only one trig function to make those. All right? So let's start doing some adjustments. So we've got a tangent. And what I usually like to do when I am graphing is in my brain, like this is like my little thought bubble, in my brain, what does this look like? And I remember that this has asymptotes when the denominator is 0 and the denominator is cosine and the cosine is 0 at the first and at the third. And then I remember tangent is that little kind of curved, swooshy sort of thing. I always think it has that properties of sort of a cubed function. Okay, so that's what I know my tangent looks like. And again, this is just something that I think in my brain. I don't write it down, I just think. When I jump into it, this is what my graph is kind of going to look like. Now I'm going to put everything together. 1, 2, 3, 4. What is this last value and why? Don't confuse the last value on my graph as the period. It happens to be for sine and cosine, but I want to know what that last value is and why. What should my last tick mark be? Pi. Yep. Pi. That was 2 pi over 2. That number that's in front of the theta is the one that tells us. Now, again, keep in mind, I'm not answering what the period of this graph is. All I'm doing is putting that last tick mark on here so that I can graph this. And so half of that is pi over 2, half of that is pi over 4, and then when I keep doing my counting, I get 3 pi over 4. Then I have 4, I have negative 4. I am going to sketch a quick cosine for my asymptotes, or not. If you don't feel like you need to do that, don't do it. That gives me my asymptotes. And then I can put my cotangent on. Or sorry, tangent on. And what's the period of this graph? How long does it take to repeat itself? Pi over 2. What's the amplitude? Not applicable on a tangent graph because I can't measure. So when we were graphing our sine and cosine, again, we kind of turned into machines where you just sort of put your stuff on your graph and then figure out which graph it had to be. We're just upping the number of choices of graphs we have. So I'm going to still set everything up the same way. I just have to decide which one I'm going to graph when I'm done. And again, use the little tricks to help you. Eventually you might just memorize what they look like. Bless you, by the way. So I have y equals the cosecant of theta over 3. I remember cosecant, you can't mix a co. So this is 1 over the sine, and that's going to help me decide where my asymptotes are. I start again, like I said, I jokingly say it's like I'm a machine. I do the same thing over and over. Put all the pieces together just like I was graphing a sine or a cosine graph. My end result will just be a little bit different. Remember that this means 1/3 theta, making this last number what? 6 pi, beautiful. Because that's 2 pi divided by 1/3. You don't divide by a fraction, you flip and multiply, so that's 2 pi times 3. My halfway mark is 3 pi. 3 pi over 2, 9 pi over 2, 1, and -1. So if nothing else, you should be able to get this done. You did it in last chapter, and when I corrected your test, you guys did great. Now I just have to put the appropriate graph on, and I do that by making my sine ghost graph either physically on your paper or, like I said, in your brain. Think about it. Think about it. When it hits the axis, that's where you have asymptotes. Then I go ahead and I do the flip. Make sure it hits that point that it shares. If you do your ghost graph, make sure it hits. Make sure that it lines up with these marks, that even though we don't have an amplitude, I still have those values on there, and that's the exact location where that floater thing is going to bottom out when it's opening up and top out when it's opening down. And I have a period and an amplitude. Again, that's not applicable. Period will follow that of sine and cosine. All right, I am going to pause, and I want you guys to graph the next two. And then we'll take a look at our pictures, see how we're doing, see if you can put it together after all my jabbering. All right, so here is my cotangent graph. I did 2 pi divided by 1/2 to get my end number, but I cut that in half when I was defining my period. I put in my brain cosine over sine, so I put in my brain what the sine graph would look like. In fact, I can put those dots on there. Again, this is cosine over sine. The sine graph has these values that help us determine where the asymptotes are. And that's why I put it on the 0, on the 2nd, and on the 4th. And then I sketched in the rest of my cotangent. As for my secant, here I am, same thing. Except for the secant is 1 over the cosine. So to decide where my asymptotes go on that one, I had to visualize where the cosine was going to cross the axis. Again, it's all about the denominator, all about the denominator. How are we doing? Any questions? Any concerns? Happy Friday, everyone, right? Woohoo! No plans? No nothing? You guys are looking at me like I'm crazy. All good? Okay, here's your homework. 25 to 28 all, 33 to 45 odds. Yes, I am taking away some of your freedom here. I'm telling you odds. And that's because we're splitting this up in 2 days, so we're going to end up doing the evens on the next. So that's your assignment. We'll get into shifts on Monday. I know you guys will dream about it all weekend. You can't wait. Can't wait. It'll come soon enough. Don't worry. Those shifts will be fun. Did I number wrong? No, I think I'm okay. 25 to 28 all. And then 33 to 45 odds. Yeah. Am I in the right? You guys are looking at, again, I feel like, what's going on? So I can stop recording.
Good catch.
Yeah.